Hello, this is Teacher Francis Omai. Welcome to my YouTube channel. We will be looking at chemistry from 2 work, and in our today's video we'll be looking at relative atomic mass and isotopes. Maybe we can start by asking ourselves, what is an isotope? We normally say that an isotope, some atoms such as potassium, chlorine, and so many others, they exist as having the different number of neutrons but same number of protons. In other words, they have the same atomic number but different mass number. Those are known as isotopes. Now we can define isotopes as atoms of the same element having the same atomic number but different mass number. Now a good example is when we talk of potassium 39 and potassium 40. This will be 19 and this one is still 19, and both of them are potassium. We can also have chlorine 35 and chlorine 37. For this one is 17, this one is also 17. Now you realize that with this one is chlorine, this one is chlorine. The atomic number are the same but the mass numbers are different. Now with that, we dive into relative atomic masses. Now with the mass numbers, there are those that exist more than the others. We call it relative abundances. Now with that, we do say that RAM is equals to percentage abundance multiplied by mass number, and the result we divide by 100 because it is in form of percentage. Now it depends with how many isotopes are present, and if there are many, we are just going to sum them up, then the answer divided by 100. We have an example here that says element P has 2 isotopes with relative abundance 65% and 35%. So if we talk of P, we have P that is 65% and P that is 35%. Now if the mass number of the 2 isotopes, now the first one here is X and the second one here is 31, and we have the RAM is given as that. With that, we can find the value of X. To get the value of X, we just use the formula here. The percentage abundance we have here, 65 multiplied by X, plus we have 35 multiplied by the next one, which is 30 or 31, and then all this divided by 100. We're supposed to get the RAM, which we've been given as 30. Now if we cross multiply by 100 to remove the denominator by 100, that means we will have 65x plus 35 times 31. We're supposed to get 1085, and with that we're supposed to get 3000. Now taking the like terms together, we have 65x is equals to, we take this to the other side, which means we subtract, and when we subtract we get 1915. divide by 65, divide by 65, and the value of x is gonna be 29.46, and that means this is the value 29.46. This is the value for the mass number of isotope with relative abundance 65. Now, another question is here that says lithium has two isotopes with mass number 6 and 7. That means if we write lithium, we have lithium 6 and lithium 7, and we have the RAM as 6.94. Now, we've been asked to find the I think there is a small error here. We're supposed to find the percentage abundances, and to do that we have the formulas with us. Now, the percentage abundance, the summation of percentage abundance is always 100%. That means if, let's say, lithium 6, we can give it x, and that means lithium 7, it will be 100 minus x, because the total should give us 100. With that, you can use the formula. We will have x multiplied by 6 plus 100 minus x. This is the percentage abundance multiplied by 7 divided by 100. This should give us 6.94. Doing that, we have 6x plus 700 minus 7x is equal to, we can multiply by 100 to get 694. Taking the right terms together, this minus this, we get negative x is equal to 694 minus 700, which gives us negative 6, divided by negative 1 by negative 1, and that means in this case lithium, the one that has x is lithium 6. Now lithium 6 is 6%, and that means lithium 7 will be 100 minus x, which is equals to 94%. It is just as simple as that. Maybe you can try one more example here. Number 3, an element X consists of isotopes with mass numbers 22, 24, and 25, and the percentage abundances have been stated. Find the RAM. Maybe you can pause for a moment and try that one out. Yeah. Now for this one, we just utilize this formula where we say the percentage abundance multiplied by mass number. Now all this divided by 100, it should give us RAM, and it is what we want, and that means the percentage abundance, the first one will be 89.6 multiplied by 22. I trust it should be respectively, and the second one is 6.4 multiplied by 24 plus 4.0 multiplied by 25. All this divide by 100, and we are going to get RAM for that. Now with that, you can do that using a calculator here. 89.6 multiplied by 22, 6.4 multiplied by 24, this one gives us 2224.8 divided by 100, and that means our RAM will be 22.224. Now we normally say that RAM is the abundance or the mass of a given isotope compared to that of carbon-12. Yeah, carbon-12 is the point of reference, and that's why we use carbon-12 to describe that. Now we have an exercise here that says chlorine 35 has percentage abundance of 75%, while chlorine 37 has abundance of 25%. Find the RAM. You can do this one as an exercise, and the answer should be 35.5. Should be 35.5. Now, in case a question is posted for you to determine which one is more abundance, you just check which one has the highest percentage, and the one that has the highest percentage always have an RAM that is close to mass number. Now if you check, this one is 22.224. if you check 22, 24 and 25, 22 is closer to the RAM, and that means that one is more abundance. It means it will have a greater percentage. God bless you. Remember to subscribe and share.